Hello, this is Lewis with a video demonstrating the use of the PredictWind DataHub to control and manage a Wakespeed regulator. So the first thing we need to do is we need to log in to the DataHub, and as usual you would Wi-Fi connect to the unit and then go to 10.10.10.1. I'm connected to my unit via Ethernet WAN connection at IP address 192.168.77.20. So we'll go ahead and use that for purposes of this demonstration. However, under normal circumstances, you would just basically Wi-Fi connect to the unit. So we first log in as admin. The default password is admin on this. You've changed that. And we notice that there is no Wakespeed app here listed under services. So the first thing we have to do is we have to enable the Wakespeed app. To do that, you log out. You log in as superadmin. The default password for superadmin is superadmin unless you've changed that. Oh, well, you got to spell it right. And again, you got to spell it right. You then navigate to NMEA under services. You go to the Advanced tab, and you'll see a button down here called Wakespeed WS500 Enable. Push that button, and that will enable the regulator, enable this application. So once you log in again as admin, you will notice that under the Services menu, you have an op called Wakespeed. So currently I have a Wakespeed WS500 Pro connected to my DataHub. I'm connected via the NMEA 2000 bus, as well as with a USB cable. So you can connect directly to the USB cable. This will power the unit and allow you to program it on the bench. So if you've got this outside of your boat before you install it and want to program it, you would need to do that. We need to, once we enter this page, we need to go ahead and select the regulator we're using. And you notice that here I have two entries. One of them is the WS500 USB, which is the DataHub interface to the regulator via the USB cable. Under normal circumstances, you would not see that because you would just basically be using the NMEA 2000 CAN bus. And then you'll see the WS500 listed here as an option. If you have two regulators, then you'll see two of them show up. If you have three, you'll see three show up. So you can pick the regulator that you want to control. You then select the regulator, and you hit save and apply. Okay, at that point we are now communicating with the regulator. Now I have my unit on the bench, and so because it's not connected to the batteries or an alternator, it's going to basically fault out. And so under normal circumstances, when you've got this connected on your boat and you turn the ignition key, this is not an issue. But on the bench, the unit was going to restart itself over and over again because it's going to fault. And so you'll see a red light come on indicating a fault code on the unit. So there's this configuration mode. If you enable the configuration mode, what that does is it disables all the external inputs into the regulator so that you can control the regulator as if it were connected onto the boat and program it without it basically rebooting itself every 30 seconds or so. So I'm going to go ahead and enable configuration mode. Note that when you enable configuration mode only takes effect when you restart the regulator. Since it's faulting, it will restart itself every 30 seconds, and so once it restarts itself, it'll go into configuration mode automatically. When you're done with configuration mode, you want to uncheck this, do a save and apply, and then restart the regulator. If you were to do this on your boat and the configuration mode were enabled, then your alternator would never put out a charge because the field is 0 when you're in configuration mode. All right. So we're now basically communicating with the Wakespeed. Now you have several tabs along the top here. They control different things, and we'll be going over some of these. But the ones starting here with AST, CST, CPE, SCV, and SST are status tabs, and they correspond to the status of the unit. And so For example, the AST tab will tell you basically the current status, running status of the alternator. So it's been running for 0.01 hours. The battery voltage is 0 because, of course, we're not connected to a live system. The number of amps coming out of the alternators, etc. So for the battery temperature, alternator temperature, the engine RPM. So status information coming from the alternator, from the regulator itself. Now, one thing to note here is that this application is really patterned after the programming guide for the Wakespeed regulators. And so the definitions of all these fields, although we make an effort here to actually define the fields in the user interface, but the detailed definition of what all these fields are and what all these tabs are is defined in the Wakespeed programming manual. So if you go to the Wakespeed website and you go to the Wakespeed page and you go to the support section and you click on the communication and programming guide, all right, and for example, if we're looking at the AST tab, we search for the AST tab. Okay, AST. You'll see here basically that AST corresponds to alternator status, and again, hours, battery volts, and so forth. So there's a one-to-one correspondence between the definition in these manuals. And so we've taken some of these descriptions, the short ones, and put it in the user interface so that you don't actually have to have the manual. But for the longer definitions, you can actually come to the manual for any one of these. And you'll know that this is true for the display. So AST, you'll find an AST, CST, CPE, SEV, and SST defined in the manual. And when you program this, as we'll see here in a bit, down here you'll see the SCA, SCT, CCN, CNG, etc. These tabs and these down here, CPA, CPO, CPF, etc., are all defined in that manual in gory detail. So again, you don't normally need to refer to the manual because we make an effort to put the definitions in the actual user interface, but the manual is the ultimate reference here. So AST is for alternator status, CST is for CAN bus status. So you got enabled. So this has got the NMEA 2000 interface enabled for the Wakespeed. And I'll just, like I said, let you poke around here. CPE, this is your current charging profile. So for example, in our profile, we want to set a target voltage of 14.4 volts. This is a lithium battery system that we've got on the vessel. Acceptance times, how many amps before you exit, and so forth. So the actual definition of the charge profile is here. So this is again status. We will be modifying the charge profile, and I'll show you how to program that and set these values. SCV corresponds to the system configuration. Again, do we have a shunt and what the polarity of the shunt is? Whether this is a 12-volt system, 24-volt system, and basic status information on the regulator. And then the SST is the system status and just any fault codes, the state of the regulator. So currently we're operational, and all the sensors are functioning, and so we're basically functioning. We're running, and then again the name of the regulator and the version of the firmware that's running in here, whether it's in a derated mode or running in normal mode, and again so forth. So again, status information. So these are your status when you're actually operating and running your vessel. AST is absolutely the most useful one, since that gives you the current state of the charge cycle and what the alternator is and the different temperatures of your batteries and your alternators. All right, so we've got the regulator connected, it's communicating. So there's several. So we've gone pretty much over what the app settings do, which is basically allows you to enable the software and select the regulator. Notice here that once the regulator is selected, the target version of the firmware is listed here, and so we are running 2.6.0, which is the latest version of the firmware. Again, the reg settings is used for programming the regulator. Now let me mention, this is kind of important, and this is true for the DataHub user interface in general. When we make changes to these forms and we hit save and apply, we're saving those changes to the DataHub. They're not being pushed to the regulator. So you can come in here and you can make whatever changes you want. You're not going to affect the functionality of the regulator or the programming of the regulator until you actually tell the DataHub that you want to send a program to the regulator to update the parameters. And so, as you'll see, we'll go through and we'll play around and set values and hit save and apply every once in a while. But again, those aren't going to be sent to the regulator until we're actually ready. So if you have a WS500 installed on your vessel that is already operating, then probably the first thing you want to do is you want to import those values so that you can edit them. There's no need to recreate them from scratch because you've already got them in the regulator. And so you'll notice that under Import-Export, the Import-Export menu, there is a button here that says Reg Import. So if you push that button, what that will do is it'll cause the DataHub to query the regulator for all of its settings. So this takes a minute. And then once it's read all of those settings, it will import them and then move you over to the Reg Settings menu here to actually allow you to start editing them. And so we can go ahead and now start modifying the program that we have in the regulator, and then save it, and then reprogram the changes back into the regulator. Alternately, if you're doing a new install, you can go under Profiles, and there's a whole list of batteries in here that are predefined that will give you a nice starting point. And so let's go ahead, rather than modify the program that's on this regulator, assume that we're going to be doing an install from scratch, and do an example here of a charging system for a lithium battery system. So I'll use my boat as an example. I have 4 300 amp hour batteries made by SFK, Sun Fun Kits, and so these are pretty standard stock lithium batteries. They're not listed here as one of the options because they haven't been, but there's other lithium batteries in here. For example, the Battleborn batteries, which are lithium batteries, which are quite similar. And so I can go ahead and use this as a starting point for my programming. So if you go to the profile and you hit the restore button, what that will do is it'll load these predefined values into the editor, and then we can go ahead and modify them as we want. And so you'll notice that the first thing is basically a description of what this profile is. You have a name, so you can go ahead and change this. I can, for example, change this to SFK, which is basically the batteries that I'm using. You can put a password on the regulator if you want. On the Pro, you can enable the Bluetooth. Select the charge profile. I guess the defaults are really good here. Feature in mode defaults. These are all things you can spend some time listening in the manual for what these things all mean. But here under battery capacity, I'm going to go ahead and enter mine, which is 2400 amp hours. Now this is important because the Wakespeed has a shunt that goes to the batteries and can meter or will meter the amps in and out of the batteries. And so you can specify, for example, in your charge cycles when you want to re-enter bulk charging mode, for example, based on the state of charge of the batteries. And so it needs to know what the size of the battery is in order to be able to use those state of charge parameters in the programming aspect of it. So enter the battery capacity. And then the battery voltage, it can auto detect it, but if you know what your battery voltage system is, mine is a lithium battery at 12 volts, so we'll just go ahead and set that. And so those are kind of the basic settings. Down here under SCA, so this is a charge alternator parameters. So very first one, temperature for your alternator. So your alternators are going to run very hot with the lithium system. You don't want to overheat them. You need to know what the maximum temperature, operating temperature is for your alternators. 100 is usually a pretty good value. The derate mode. So this is under normal conditions. So this is going to take down the field from its normal. So 1 is basically 100% output. Since we're running a lithium system and lithium batteries require a lot of current, I like to run mine at 0.9. so that I'm not basically overusing the alternators. I run them at 90% instead of 100%. Again, for these other derate values correspond to smaller or error conditions. So, for example, if some condition is met that the regulator decides it needs to be running in reduced speed, for example, you short out the temperature sensor. I have a switch on the dashboard that allows me to do that. Then I can set basically the field that it comes out of that unit. In this case, 75%. But you could also do 50% based on. So, for example, if I hit the alternator, if I short out the alternator, I have that set so that it gives me 50% power. So if I'm putting out 200 amps out of my alternator and I short out the temperature sensor with the switch on my dashboard, then I put out 100 amps instead of 200 amps. And again, so forth, the shunt ratio, I have a 550 millivolt shunt, 500 amp, 50 millivolt shunt on the Wakespeed. So if you're using that, then you would use 10,000, but you enter the ratio for your shunt. Shunt polarity is on the negative side of the battery. If it were on the positive side of the battery, you would change the polarity there. And then, again, other options. So required sensors, this is kind of an important one. This will cause the alternator to fault if some of the sensors are not working. So for example, if you've got a battery sensor and an alternator sensor, you want to monitor those. So you want to enable those. Again, the current shunt, you can turn that on. I normally leave that off. And then force fault mode, if you have this checked, what will happen is if the regulator faults, it will stay off and it will not reboot itself. If you have that unchecked, what will happen is you'll get a fault light. The regulator will restart itself and try to recover from the error and start to operate again. But again, that's an option in a description of how this works. It's defined in the manual. Ignore sensors. If you're not using one of the sensors, you want to basically ignore it so that it doesn't affect the function of the regulator. I, for example, get my RPMs over the NMEA 2000 bus using a mechanical transducer on the engine. So I don't want the stator line to be monitored, so I'll just ignore that. Again, this is defined in the manual. So these are all Wakespeed related things and really not DataHub related things. And again, I refer you to the programming manual to read about how all these features work. All right, so let's go back down to the charge profiles now. Well, before that, let's go over here. SCT corresponds to the tachometer. So if you're using the stator for your RPM, you want to enter the number of poles and the drive pulley ratio for your engine. Otherwise, you won't get accurate RPMs coming out of the stator going into the Wakespeed. CCN stands for the CAN bus configuration. Really nothing to do here. You just want to make sure that NMEA 2000 is enabled and OSE is enabled. Otherwise, the regulator will not be able to communicate with the DataHub. And then again, the shunt is on the battery. If your shunt were on the alternator, you would change that. And again, I refer you to the manual. CNG is a very interesting one. This corresponds to the white space, and what this means is that you can control the field coming out of the alternator, going to the alternators, and hence the amount of power that is required from your engine to push your charging system based on the RPM of the engine. So for example, if you come here and enter 2800 for your engine, which is what mine is, and then you refresh these labels, what will happen is you have ranges down here, and you can say, CNG, so let's see, yep, you can come down here and you can say now, for example, that from 0 to 3, you want 5% of the field when you're running at low RPM. So if you're in idle RPM, I idle around 500 to 600. I really want to put out about 25% of the field so that the alternators don't overload my engine when I'm idling. But once I'm now at higher RPM, I can go ahead and increase the field to, say, for example, if I'm below 1050 at 60%, and once I'm above 1100, then I want to basically go to full speed. and full speed. But once I start reaching higher RPMs, I probably want to decrease my speed so that decrease the output of the alternator so that I don't overload the engine. And again, you can play with these values. And these, for people with large engines on their boat, they really don't need to worry about this. But for people with small engines like I've got, you might want to consider this. Anyway, it's a really super nice feature. And so I encourage you to play with that if you feel like you need it. CDD stands for the charge parameters from the DC-DC. This only applies if you have a Wakespeed DC to DC converter, and so we won't cover that here. All right, so we've made some changes. I'm just going to go ahead and just hit save just so that I don't lose them. You notice I have 32 changes up here. But again, none of these are being pushed to the regulator, and they won't be pushed until I do a save and apply and actually program. So let's take a look at some of the charging profiles. So CPA is the accept parameters. So for this battery system, we're going to basically put out as much current as the alternators will put out until we reach a voltage of 14.2 volts. Once we reach a 14.2 volts, we will continue to run at 14.2 volts for 30 minutes or for 5% of the capacity of the bank. So again, this is why you would need to enter the capacity. So 5% of the capacity of the bank, for me, that would be we're going to do the math. It's going to be about 12. It's going to be about 120 amps. So once that is reached, then what we're going to do is we're going to exit the accept mode. So we're going to put out a huge amount of current into the batteries until we are down to 5% of the capacity of the batteries. In other words, the batteries are almost full, and the number of amps going into it corresponds to 5% of the capacity of the battery bank. Then what we're going to do is in this particular profile, we're going to switch over to the overcharge profile. In the overcharge profile, what we're going to do is we're going to limit the number of amps going into the battery. So we're going to put out full amps into the battery out to 14.2. And then once we reach 14.2 and we reach this 5% of the battery capacity threshold, we're going to switch over and we're going to run at up to 14.4 volts at a much reduced amperage. So we're just going to slow down the charge. So we're not going to put in full blast to 14.4. We're going to reduce that just to kind of soften this tail end of the charge cycle for these lithium batteries. And we're going to run for either 30 minutes or until we see 15 amps coming out of the battery, going into the battery. All right, so I've got 8 batteries. I don't like that number, that's too big. I'm going to set that to 40 amps, which means that each battery is going to accept 5 amps. So when I see 14.4 volts going into my battery and 5 amps going to each battery, then I'm going to say I'm done. And so, or if 30 minutes is up, I'm going to say I'm done. So the lithiums are going to be pretty full because once they're above 14 volts, they're getting full. Once these parameters are met, I'm going to go over to the float section. I'm going to float for 13.4 volts, and I'm going to basically say that I am going to put in this profile. It's going to say I'm going to put 0 amps. So for this thing, for this profile as defined here, it's going to say, well, once you reach 13.4 volts, once you go to float, basically just turn off the regulator. And so that's just going to shut it down because it's going to put out 0 amps. Well, I really don't want that. I really want to float my batteries at 13.4 volts and just keep them there so that my DC loads on the boat are coming from the alternator and not from the battery itself, which is where they would be coming. They would be coming from the alternator anyway. But I just want to keep them floating. There's no need not to float them, and so I'm going to say this -1 to disable that. And then again, I want to revert back to charging into mulk mode when I either I've reduced the capacity by 10%. That'll never happen because again we're going to continue floating the boats at 13.4, so we're never going to draw anything out of the batteries. But and then again, if for some reason the batteries get down to 13 volts, and we're going to recharge the cycle as well. So again, these really don't matter. I'm just going to ignore those, and then we'll hit save. Okay, so for CPP, so this is a post float. We're not going to do anything with that because we're going to float it. We're not going to worry about post float. Post float means that once you've finished the float cycle, you can actually go to a storage cycle. But if you were doing a 1 month passage or something, you might want to do that. We don't need to equalize the battery, so we're not going to worry about that. And then CPB has to do with the battery charge parameters, and the important things here are the temperature. And so the Wakespeed will not charge these lithium batteries if the temperature is above 45 degrees centigrade. You can change that. And again, here it'll if the battery rises above this, then it's going above 42, then it's going to reduce the field to try to keep the number of amps going into the batteries down so that it doesn't overcharge them. And the max bat, so I have 400 amp hours worth of capacity. I can certainly put much more than 250 amps in there. I have two 255 amp alternators on my boat, so I'm just going to say that that's 400. Again, what we've been doing here has really nothing to do with the DataHub itself. It's just programming the Wakespeed appropriately. All right, so now I've got my charge profile done, and I want to program it. So to do that, what I do is I go to Tools, and I hit the programming button. All right, so here we are. We've got the programming button. So any errors that you see will show up here, and this is dynamic and will change. We notice that the alternator is off because it is in configuration mode, so I'm not sure why we got that error there. When I hit the program button, this is the Wakespeed program that gets generated by the DataHub. Again, this is the program that is defined in the programming manual, so the DataHub takes care of converting the web UI into this program. And then you hit the commit button. Once you hit the commit button, what will happen is we will transfer that program to the regulator. And so you'll see each one of the lines being sent to the regulator one by one. And if there's any errors in sending it, you'll see the errors here. But you can do this on a live alternator, on a charging system, on a running boat. So you can change the profile at any point. So you can monitor the AST tab. And if, for example, you don't like the voltages at which you're floating your batteries, you can come in here and change the float voltage, and then you can go ahead and hit the program button and dynamically update your program. After that, after it's finished downloading the program, it will reboot the regulator, which is what it's doing now, and then the regulator will come back into mode, and you will notice that we're in configuration mode and we're off and running, right? So that's all there's to it. So I can go back and make modifications, check AST, and write these things as I need. Once I'm finished with the program, I probably should save it. And the way you do that is you go to Profiles, and you can come down here and hit Add. And when you do that, you'll see that there's a new line at the bottom, and you can give this a name. So I'll call this a demo profile. And then you can hit Save and Apply, and that will save your settings. That will save the settings that you have under the Reg Settings tab into that profile. So you can actually create as many profiles as you want, and then at any time go ahead and restore them. So if I hit the Restore button, what that will do is it will take this profile and it will put it back into Reg Settings. Now if I come in here and for example, I want to change the name of any of this, to change these values, SFK, and I'll do Save and Apply here. I should say that you should do the Save and Apply on these forms before you program your regulator, so that you're sure that they're actualized in the DataHub. And before you come back to profiles and you do the operation that I did. Now, I made some changes to the profile, so I can come here and I can say refresh. And what that will do is it'll take whatever is under the reg settings tab and it'll overwrite what's in the demo things. And so again, now I've made that modification on the name. So if I go back to the profiles, and then I say restore, you'll notice that it'll go ahead and put those back and the name will be changed on the regulator. There it is, see? And then if I want to go ahead and program that, I can either go to Tools and hit Program, or I can go from Profiles. If I know that that's the profile that I want to put on the regulator, I can go ahead and say Program, and that will take that profile, move it into reg settings, and directly send it to the regulator. So here's the program here. You notice that we have the new name. There's the name right there, and we can hit the commit, and that will go ahead and send that new program to the regulator. All right, so we're transferring data to the regulator. Now, a couple more items here under profiles. You can go ahead and you can export this profile and save it. That will store a copy of that profile on your computer, and then you can mail it to somebody, or you can store it as the backup. And then you can come in here to the import, and you can import an exported profile so that you can actually transfer these between DataHubs. So if you're doing something, if you're configuring, if you're a tech and you're configuring something for a customer, you can email them the profile and then they can go ahead and import it. A good thing to do here is a backup. This will back up all of the profiles. So if you're a technician that is actually doing a lot of these for different customers, you'll have a profile for each one of the customers. You might want to back these up periodically so that if something happens to your DataHub, you can go ahead and restore them. So there's lots of things that we can cover here, but I'll let you push the buttons. But one of the things that we want to do at some point is a firmware update. The DataHub will do firmware updates for the Wakespeed for you. That's done here under Tools. Currently it requires you to have a USB cable connected to your Wakespeed. Future versions of the Wakespeed firmware for the Pro will allow you to do this over the CAN bus. I'm really looking forward to that. But for now, the Wakespeed Pro and the Wakespeed can only be upgraded via a USB cable. So you would connect a USB cable between your DataHub and the regulator. I've already got that. So you would come in here and pick the version of the firmware that you want. So the only firmware that's packaged with the DataHub is the latest version, in this case 2.6.6. You just hit the upgrade button, and at that point, that will go ahead and start programming the firmware. And so you'll see here that we'll put the regulator in DFU mode, which is a special programming mode for the regulator, and then it'll update the firmware. And so we're now in process of updating the firmware. And when the firmware update is completed, it will let you know, and then at that point you need to restart the regulator. So the firmware is complete, and so it wants us to restart the regulator. Now restarting the regulator is a manual operation, so I'm going to go over here and just push the reset button, and that will restart the regulator, and then we're back in action. So firmware updates are pretty simple. Usually I release a new version of the DataHub firmware for every Wakespeed firmware update. Firmware updates from Wakespeed happen about once a year, and so we just make sure that we have the latest version of the okay, so we're back on regulators, back online now. Yeah. So and if you go to the AST line, you'll see that basically we're up and we're operational again. So we're still in configuration mode, but the regulator is functioning. So that's pretty much it. There's some other diagnostic tools in here, and I'll let you poke around, but that's basically it. So the managing the regulators is pretty straightforward, and tuning them is quite easy. And so again, the operation is use AST, check the values. If you're unhappy with the way your charging system is working, then go back and modify your profile, and then hit save and apply, and then program it. So that's all I've got for you. Anyway, enjoy. Any questions, send me an email. Thanks.